Alright, now we move on some of the geometry concepts. Let's take a look today. Take a look at the lines and angles. Before we move on to lines and angles, let's take a look. We are living in a space, right? So let's come back to the little dot. That is a point. Point has no dimensions, no length, and no height. So usually we say use the capital letter to represent a point, like a point P. And line is a set of points extending into two dimensions. And then we have a line. This is a line with arrow indicating that the line is going to two directions infinitely. And sometimes we can name this line saying line L. Or you can pick up a point, 2 points on the line. A and B are the line on the point. Sometimes we call that is line AB. Or you can just use AB per head with the line symbol. That means a line without any endpoint extending to both sides. Line segment is the one we can measure. Tell how long it is. For instance, I have a line segment with the two endpoints. Let's see, CD. So this is line segment CD, which we can measure how long it is. And rate. The ray, just like the sun, you have the sun for that's the endpoint, and you have the line ray going to one direction infinitely. So it's a part of the line. This is called ray. And for instance, if I put A in this endpoint and I pick up any point on the ray, right? So this is called ray AB, or use symbol we can indicate A, B with the head arrow going to this side. So we know that A is an endpoint. Alright. How about angle? An angle will make up by two rays. Let me draw an angle. So that they're sharing the common vertex. This is we call vertex. And let me call this A. And give you a point B right here, point C right here. So this angle can be named as angle BAC. So this one, the middle one, is the vertex of the angle. Or in our case, we can just call it angle A. Or we can call it angle, we can do backwards, CAB. Or if I put an X right here, this also can be named as angle X. So the ray AB, this is called the sine of the angle. That is the sine of the angle. This is two rays for that. Alright. Let's take a look at other angles. Let's go over how to name our angles. Okay, I'm drawing tons of angles here. They all share the same vertex T. And that's a point P, Q, R, S. And this may be angle Y, angle Z. Let's take a look at the angle Y. Different way we can name angle Y. Angle Y, we can name it you can use this one, but you cannot say angle T, because angle T, you don't know is this angle or that angle or the whole angle, right? So angle Y, I can name it as angle QTR or angle RTQ. For similarly, angle Z, I can name it as this one, angle RTS or angle STR. But you cannot say angle T. Okay, angle T is not the same as angle Y. It's not the same as angle Z. Now, since we are talking about angle, then we are going to see what kind of angles we have. Okay? An angle, how to measure an angle? We say an angle can be measured in degree. Degrees is like little circle on top of that, so simple. So the whole, for instance, if you have a line ray in here, and then you rotate the ray, and until you overlap with this line, so the rotation I just did right here, that is 360 degrees. So that is a full revolution. Now, how of this whole rotations, you can see an angle looks like this. And where your vertex right here, let me call it S, T, R. We can see angle, this is an angle, T, S, R. We call it is a straight angle. Which is the measurement of this straight angle, TSR, is equal to 180 degrees. Right angle is a quarter of the full revolution. Usually we use this to indicate it's a right angle. A, B, C. Angle A, B, C is the right angle. Now that the measurement of angle A, B, C is equal to 90 degrees. So right angle. And for the Q angles, it's angles measurements between 0 degree and 90 degree. So if the measurement of an angle is between 0 degree and 90 degree, that we call as an acute angle. So you can see an acute angle, maybe looks like this, okay. Or it can be something looks like this. And those angles are acute angles. If you're curious to see what's the measurement of the angle, we can measure them. Okay, use this overlap with the vertex and measure extending this. That's 48 degrees. For instance, what's the measurement of this one? And that's exactly 50 degrees right here. So those are the acute angle. The obtuse angles are the angles whose measurement is between 90 degrees and 180 degrees. Let's take a look at this angle. And maybe I'm trying to graph an angle is 140 degrees. Okay, this is the obtuse angle. Essentially between 90 degrees and 180 degrees. Alright. How about some relations between some angles? If we say complementary angles, that means two angles that have a sum of 90 degrees. That's called complementary angles. For instance, I have angle R. Let's say this is 75 degrees. And then I have an angle S. Let's say it has 15 degrees. The measurement of angle R plus the measurement of angle S, which is 75 degrees plus 15 degrees, equals 90 degrees. Then we call angle R and angle S are complementary angles. Because the sum of the measurement is equal to 90 degrees. Then another pair of angles, we have the relationship called supplementary angles. It still is a relation between two angles that have a sum of 180 degrees. That's called supplementary angles, or they call supplement of each other. So, for instance, if I have an angle M, an angle M have a measurement is 150 degrees, and then I have angle N, whose measurement is 30 degrees. Measurement angle M plus measurement of angle N is equal to 150 degrees plus 30 degrees is 180 degrees. Therefore, we call angle M and angle N are supplementary angle. Alright, let's go back to take a look at the supplementary angles and complementary angles. That all is about two angles relation. It's not 3 or 4, it's a pair of them. Let's take a look at another example. We are going to find the supplement of a 67-degree angle. Well, first we need to understand what supplement of angle. That means two angles sum is 180 degree, and if I know one angle 67 degree, then the other angle's measurement should be 180 degree. Subtract 67 degree. That will give us 113 degree. So the supplement of this 67 degree angles is 113 degrees. Alright. Before we move on to more new concept, let's go back to revisit all different kind of angles by doing these problems. I'm going to give you a figure. And we have different angles in here. This is X, we don't know this one. From here to here is 50 degrees. And this looks like a right angle, but it's not. And from here to here is 87 degrees. We are going to find the measurement of angle S. You see angle S and angle this STR form the angle STQ. So angle S measurement should be equal to measurement of angle STQ. Subtract the measurement of angle STR. STQ measurement is 87 degrees. Subtract the 52 degrees. That will be 35 degrees. Alright, this angle's measurement is less than 90 degrees. And also this number is greater than 0 degree. So from here, we know that angle RTQ is an AQ angle. Okay, are we ready to move on? Those are the 1D, one dimensions. Let's move on to some 2D figure. And before we do the, sorry, too fast. Before we move on to the 2D figure, let's take a look at more lines. Okay, lines, some lines relations. In one of the relations below, we are going to talk about in a plane. Okay, we are not going to talk about the relations in a space. We are talking about in a plane. In a plane, the line, if you draw two lines, they might be, let me call this line L, and this is line M. Okay, so the line can be intersecting at a point, maybe just call point. This is intersecting point. Right. Or you can have relation as the line that they do not intersect to each other, they parallel. Let me call this line K and line Q. Okay, so these two lines are parallel. In mathematical symbols, sometimes we call line K is parallel to line Q. For the intersecting point, sometimes line we have some special cases, which is you have two lines intersecting to each other. They are going to form a right angle right here. let's say line M and M. Okay, this called perpendicular line. So which is M is perpendicular to M. Alright. Let's go back to two lines are intersecting to each other. I have two lines intersect to each other. You can see this line cut into 1, 2, 3, 4 angles. Okay, let me call this angle 1, angle 2, angle 3, angle 4. And the two angles are opposite from each other. Like these two, they are called vertical angles. So you can see the opposite angle in our case, angle 1 and angle 2 are opposite, right? So we call that they are vertical angles. Same idea, angle 3, my mistake, angle 3. Angle 2 and angle 4 are vertical angles. And the angles who are next to each other, for instance, 1 and 2. Okay? They are not next to each other, share a side. So those called adjacent angle. So that means two angles that share a common side. They call adjacent angle. For our case in here, angle 1 and angle 2 are adjacent angles. And angle 3 and angle 4 are adjacent angle. 2 and 3, they are also adjacent angles. And 3 and 4, and also 1 and 4. Those are adjacent angles. The adjacent angles formed by intersecting lines are supplementary. Okay, so those adjacent angles, they're also supplementary angles. So apply for the others. Because the sum of the measurement is 180 degrees, they form a straight angles for that. So those are for the intersecting lines. For the parallel lines, we have some special angle as well. I know for this section, we do have a lot of terminology. We need to memorize them. Right. If I have two lines, let me call this line L, M and N. And then you have a line L intersecting these two lines. So this is called transversal, because the transversal is the line that intersect at 2 or more lines at different points. See, they intersect at different points. We call this point P, point S. That's called transversal. And you can, let me name all those angles around this way. 1, 2, 3, 4, 5, 6, 7, 8. Among those 8 angles, we have some corresponding relations. The one we call corresponding angles are angle 1 and 5 because they are all on top of this line and on the left of the transversal. Angle 1 and angle 5. Similarly, if you find the corresponding angle for angle 2, that will be angle 6. Corresponding angle 3 is angle 7 and angle 4, angle 8. They are corresponding angles. The alternate interior angles. Okay, interior angles like inside, right? So this one is interior. So the corresponding is alternate, by alternate on the opposite side, angle 2 and angle 8. They are alternate interior angles. And so this one will be angle 5. So angle 3 and angle 5. They call alternate interior angles. If the line L, my mistake, the line M is parallel to line N, and they both cut by the transversal L, then these following statements are true. The corresponding angles are equal. The measurement of the measurement of corresponding angles are equal. So for our problem, we can see the corresponding. So between the angle 1's measure should be the same as angle 5's measure. Angle 2's measurement should be the same as angle 6. Angle 3's measurement should be the same as angle 7. And the measure of angle 4 should be the same as angle 8's measure. And also, the measure of the alternate interior angles are equal as well, which means the measure of angle 2 should be the same as the measure of angle 8, and measure of angle 3 should be the same as angle 5's measure. Let's take a look on example. I have these two lines who are parallel to each other. Okay, M and N are parallel to each other, and they both cut by the transversal L. And what else we are given? We are given this angle is 45 degrees. Let me call this as angle W. And we are going to find the rest of the angles measurement. Okay. A, B, X, C, D, Y, Z. Let's find the rest of the angle measurement to see if we can do it or not. Alright, let's see. Angle W and angle Y, they are corresponding angles. Therefore, the measurement of angle Y should be the same measurement angle W, 45 degrees. So this line is 45 degrees. And let's take a look. Angle X and angle W, they are vertical angles. For vertical angles, their measurements are the same as well. Right? So this is 45 degrees. Similar idea, angle Z and angle Y are vertical angles, so angle Z is 45 degrees as well. Let's go back to angle W. Angle A and angle W, they are supplementary angle. Which means the measurement of angle W plus the measurement of angle A will give us 180 degrees. Then the measurement of angle A, that should be 180 degrees, subtract 45 degrees, that will remain 135 degrees. So this one is 135 degrees. Oh, 35, not 30. Similarly, these are corresponding angles. So angle C measurement will be equals to 135 degrees. Again, they is a corresponding angle of angle A. Angle A is the vertical angles of angle B, and angle D is the vertical angle of angle C. The measurement should be the same. So measurement of angle B, that will be 135 degrees, and so does angle D. Okay. So those are 135 degrees, 135 degrees. All right. So that will be conclude today's lesson, and next time we are coming back to continue learning geometry. We are going to move on to the 2D case with the plate and 3D which is the solid. See you next class.